started on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to take a look at string comparison operators and methods you can use with if statements. This is going to be all about how we can evaluate and process strings, which are text values. On the screen right now are the comparison operators, and we saw this before in a previous video, but this time all these examples are for strings, because we can also use comparison operators on string values, just like we saw with integer and float values. And they work similarly, but there are a few quirks we should talk about. So for equality, that's the two equals signs put together, it returns true if they're equal, but equal in this case means that these strings have to be identical, including capitalization, spaces, and anything like that. So if the strings are spelled differently at all, they have different capitalization, they have an extra space, or an extra punctuation mark, then they're not going to be considered equal. For example, cat in all uppercase is not equal to cat in all lowercase. That's going to return false. Not equals is the same idea, except the opposite. So if the strings are not identical, it's going to return true, like cat not equal to dog is fine, that's going to return true. But something like duck not equal to duck will return false because those are identical. But keep in mind, if the capitalization was different, like if we had duck in all uppercase not equal to duck in all lowercase, that would return true because the strings aren't identical. So greater than and less than might work like you expect. It's comparing the alphabetical order of the strings. But the one quirk here is that capitalization counts differently. So a capital letter is considered to be coming first alphabetically before a lowercase letter. So that means that a capital Z would be come first alphabetically, a lowercase a. So you can think of it as the whole uppercase alphabet first, and then the whole lowercase alphabet. We can see some examples on the screen here. We have cat greater than dog, and that is false because it's saying that dog comes later in the alphabet. Later would be greater. So because cat comes earlier in the alphabet, then this is returning false. Cat is less than dog. The other one, dog greater than cat, is returning true because dog is later in the alphabet. Duck greater than duck also returns false because, as you recall from before, greater than doesn't count two values being equal as one being greater than the other. We have to use greater than equals for that. So duck greater than duck is going to be false because they are identical. Less than probably works the same way you think. A less than B returns true because A is first alphabetically. Capital A less than lowercase a is true because, like I said, all the uppercase letters come first. So lowercase a less than a is going to be false because it's flipped around. The lowercase letters come after the uppercase letters. A less than a, again, is going to return false because they are equal. And equal doesn't count for less than, only for less than equals. Next are greater than equals and less than equals. And these are the same as greater than and less than for these string values, except just like with the integer and floating point values, they also include cases where the values are identical. So for example, cat greater than equal to cat is true because the values are identical. Duck greater than equal to cat is also true because duck comes later in the alphabet. It has a sort of greater value alphabetically. Now looking at the less than equal examples, we can see that duck less than equals duck is returning false because the second duck has different capitalization, meaning it's going to happen first in the alphabet. So duck with a capital D happens before, it's earlier in the alphabet, than duck with a lowercase d. The next example, duck less than equal to duck, returns true because those strings are identical. So we talked a little bit about capitalization, and the issue is that uppercase and lowercase letters aren't treated as the same, and they're sorted different alphabetically. So for example, lowercase a would be greater than uppercase z because a comes later alphabetically. And we're talking about greater, we're saying that it comes later alphabetically. And that's because all the uppercase letters come first and then the lowercase letters. So this would return true. Next, we're checking if lowercase a equals capital A, and again, that's going to return false because they're not considered to be identical. So one easy way to fix this would be to convert the capitalization, but let's take a look at the problem again. So in this example, we have x equals apples and y equals bananas. And we have a very simple if statement. It's comparing them with the less than operator. So if x is less than y, we're going to print out x less than y. If that's false, then we print out y less than x, where x and y are the values of those strings. So if we run this, we would get bananas less than apples. But the problem with this is most people wouldn't really consider to be bananas to come before apples alphabetically. It makes sense in the context of all the uppercase letters coming first, but for a normal human, that doesn't make a ton of sense. Let's see how we can fix this. And you can see the code's been updated with two things. And that is we added .lower to x and we added .lower to y. If you recall from earlier videos, the lower method for strings converts that string into all lowercase, so bananas would become bananas in all lowercase. Now when we run this, we would get apples less than bananas. So the solution, if you want case-insensitive comparisons, is to convert everything to the same case. That could be converting everything to lowercase or converting everything to uppercase. It's important though that they all go to the same case. So always go all lower or all upper, not a mix. Let's take a look at a more complex example. In this case, we want to create a Python program that asks the user to input 3 words, and then it prints out the word that comes first alphabetically. So if we put in cat, dog, and zebra, we should get cat as the output. And we want to ignore capitalization. So here's the solution, but let's go through how this works. So the first bit you should be familiar with by now. This is just asking them to input 3 words and then inputting those 3 words into variables word1, word2, and word3. Next, in our if statement, we are using .lower. We're doing this to ignore capitalization, so we convert everything to lowercase before we do the comparison. Remember, this doesn't actually change the value stored in word1. Instead, it returns a new string that's in all lowercase. So it won't update the value in word1, but for these comparisons, it will compare them as if they were all in lowercase. So this if statement here has 2 conditions that it's joining together with an and. The first one is checking if word1 in all lowercase is less than word2 in all lowercase. The other condition it's checking is word1 in all lowercase is less than equal to word3 in all lowercase. So basically, we want to know if word1 is the first word alphabetically. So if both of these are true, if word1 is less than word2 and word1 is less than word3, we know it is the first word alphabetically. In that case, we are going to print out the value of word1 because we've figured out that it's first. Next is the else if statement. And this is only going to be run if word1 is not the lowest. Because we already evaluated that. So the else if is only going to be run if the first condition was false. In this case, we're doing the exact same thing, but with word2. We're checking if word2 is less than word1, as well as if word2 is less than word3. If it's less than both, that means it's the lowest, and we're going to print it out. Otherwise, if both of those are false, word1 isn't the lowest, word2 isn't the lowest, then by process of elimination, the lowest word has to be word3. And we print that out. Okay, so here's an example if we ran it with cat, dog, and bunny, with cat in all uppercase, dog with a capital letter, and bunny in all lowercase. Capitalization is ignored because we're first converting the strings to lowercase before we compare them. And bunny is output as the result, as we did those comparisons, and both word1 wasn't the lowest, word2 wasn't the lowest, so by process of elimination, it has to be word3. As another example for input, let's say we have duck, cat, and zebra. In this case, cat is going to be first alphabetically. But there is another way to write this, and there are some improvements we can make. So in this alternative solution, what we're doing now is instead of converting the string to lowercase before comparing it, we're converting it to lowercase right away. This has a few trade-offs. It's a little bit cleaner code, but it does actually change the value of the word before it's stored in the variable word. So this means when we output the word, it's not going to have the capitalization anymore. It's going to be in all lowercase. The other change we made was to the condition of this else if statement. Before it had a second condition that was word 2 is less than equal to word 1. But that was unnecessary. But why was it unnecessary? Well, if we took a look at the first condition in the start of the if, we're basically checking if word 1 is the lowest. And the only way we will get to the else if is if word 1 is not the lowest. This resulted in a false. So that means at the point at the else if, we already know word 1 cannot be first alphabetically. It has to either be word 2 or word 3 because we've already disproven it's word 1. So the only check we need to know is it word 2 or word 3 that's first alphabetically? So all we need to do is check, is word 2 less than or equal to word 3? If it is, we're going to print out word 2. Otherwise, we know it's word 3. So this gives us a little bit of advantage in that this code's a little bit more readable when we do this, even though it's essentially effectively the same. There also might be a very, very slight performance difference in that we're doing one less comparison, but that's probably so small you couldn't measure it. Okay, now on to some new operations that we haven't seen yet. And these are the membership operations, and they allow us to check if an element is in or not in a collection. And if you recall, strings are a special type of collection, and they are a collection of character values. And we can use in and not in on strings, just like we could for any other collection. And what they do for strings is they check if a substring is in or not in a larger string. So by substring, we mean that it is part of a string. So if our string was hello world, a substring might be the word hello, or it might be the word world. So a smaller part of a larger string. Based on that, the in operation probably does what you expect. It checks if a string is contained in another string. If it is, it returns true. Not in does the exact opposite. It checks if a string is not contained in another string. And just like with the other operators we saw, this is a case-sensitive comparison, which means capitalization does matter. Let's look at a few examples quickly. So hello in hello world, that's going to return true because the word hello appears in the word hello world. But if we change the capitalization a little bit, now the hello in hello world is capitalized as well as world, we're going to get false because capitalization matters. So lowercase hello doesn't match uppercase hello. We couldn't find lowercase hello in this string. So here's another one. We're looking for duck and we're saying not in I love cats. So the word duck doesn't appear in the string I love cats, so this would return true. Now, if the string was rubber ducks, so duck not in rubber ducks, this is going to return false because it did find a match here. It found the word duck in the string rubber ducks. So an important thing about this example is it doesn't matter if the word is part of another word. Duck matches even though there's an S and an exclamation mark in the string. As long as it can find duck anywhere in that string at all, it's considered to be in that string. Since we're using not in here, it's returning false because it did find it. This can be a problem though, because it can give unexpected results. Like if we're looking for the word in the bad in the string I like badgers, it's going to return true because we found the word bad in badgers, which might not be what we expected. So it's important to keep this in mind that it's not smart enough to check if it's its own word. Okay, let's look at another more complex example. In this example, we want to write another program, and this program inputs text of a tweet, or it could be any text really, any comment from the user, and it outputs the text, tweet is inappropriate if it contains a bad word. And for this example, we're just going to be silly and say the bad words are bad, unhappy, or sad. Otherwise, the output should be the tweet as it was entered from the user. And the check for bad words should be case insensitive. So if these bad words occur anywhere at all in the string, we want to output tweet is inappropriate. Otherwise, we want to output the tweet. So what would this code look like? Well, we have an example here, and the main logic is going on where we've highlighted it. So the first, we're just inputting a value from the user. We've done that many times now. But now the check is the word bad in the tweet converted to lowercase? Or is the word unhappy in the tweet converted to lowercase? Or is the word sad in the tweet converted to lowercase? We We have to convert to lowercase because we want this to be a case insensitive in comparison. So just like those other examples we saw with the operators, the comparison operators, we have to convert to lowercase with the in operator if we want to make sure the check was case insensitive. If any of these are true, because we're using or, if bad is found in the tweet, or unhappy is found in the tweet, or sad's found in the tweet, we then are going to print out tweet is inappropriate. If those aren't found, then we're going to print out tweet is acceptable, and then a copy of the tweet. Let's take a look at what the running this would output. So if we input the text, this is an acceptable tweet, it's very happy, we would get tweet is acceptable, this is an acceptable tweet, it's very happy. The reason why is the words bad, unhappy, and sad don't occur anywhere in the text that we entered. But what if we said this is an unhappy tweet that is unacceptable? Well, in this case, we're going to match the word unhappy. It happens right after the word and it matches the second condition in that bigger conditional statement. So unhappy in tweet.lower would return true, and since this is an or statement, if any of the values are true, it returns true. So we just get tweet is inappropriate. But there are some areas for improvement in this example, and this is something we'll get into in later weeks. The first issue is that it's going to match words that are contained in another word, such as that bad in badgers that we saw before. So for example, if we said my favorite sports team is the Badgers, we're going to get this tweet is inappropriate because it detected bad in the word badgers, and that's probably not what we want. The other issue is it would be a pain if we had thousands of words to check like this. Imagine how long that if statement would be if we had a dictionary of 1,000 bad words that we had to censor. That would be a lot of code. So in later weeks, we're going to figure out how to use collections as well as loops to automate that. So it doesn't have to be a massive amount of coding. We can code a generic solution that will check for anything in our list. But we can't do that yet until we learn about loops and collections. So the last thing we should really focus on are string methods for comparisons. So we saw a bunch of string methods in our earlier video on strings. They did things like replace certain words in a string or count certain words in a string. But there are a number of other string methods that are really helpful when we're dealing with things like comparisons. So here's a few here. And the first one is endswith and startswith. These methods both take a substring, which is another string, and they return true if a string starts with or ends with the provided string. So in this example here in the right for the results column, we're going to assume s is equal to the string hello world. If we said s.endswithWorld, it would return true because it detects that world is at the end of that string. If it was hello world ! This would return false because it would be slightly different. Then the second example is for the startswith method. In this case, we're looking for the word world and the string s, which is hello world, but specifically at the start of the string. So this will only return true if the first part of the string is equal exactly. In this case, world is only found at the end of the string because it's hello world. So because hello isn't equal to world, this returns false. So if it starts with and ends with, it can't be found anywhere in the string. It has to be specifically exactly at the beginning with ends with, and specifically exactly at the start with starts with. The next operator here is a little bit more complicated, but they are find and index. What these do is they take some substring and they search the string for an occurrence of that substring. And if it's found, it returns the index where that was found. Remember that strings have an index. Each different character in the string has a different number value starting at 0, going from the left to the right. And this will tell us where it was found exactly. But do note, it's only the first occurrence. So for example here, if we're doing s.find O, it's going to find the first O at the end of hello. And we get an index of 4 because it is at the fourth index. It's 4, not 5, because the indexing starts at 0. So 0 would be H, 1 would be E, 2 would be L, 3 would be L, and 4 would be O. We can also do more than one single character. We can do s.find LLO, and that matches a substring in the bigger string hello world, and that occurred at index 2. It tells us the first character that substring occurred at. So we get a 2 here. So there is one special case for find an index that I should point out, and that is if it can't find the substring in the larger string. For example, here we're searching for duck in hello world. Obviously, duck doesn't occur in hello world. So what find does is it returns -1 to indicate that it couldn't find the substring. Now, there is a small difference between find and index, and that's how they deal with this special case. Find returns -1 if the substring is not found, whereas .index method will return an error message. So if you want your program to give an error when you can't find the substring, use index. If you want it to return -1 and that you can deal with that, you use .find. So the next method we want to look at are very similar. It's rfind and rindex. They're the exact same idea as find and index, except they start searching from the right-hand side. So in the example right here for rfind, we're searching for the letter O in the string hello world. This time though, it finds the O in world because it's starting from the right-hand side and moving to the left. So it returns an index of 7 because it's the second O. Similarly, in our second example, where we were doing rfind for the letter L, it's going to find the L in world, which is the second last character, rather than the first L in hello. So rfind searches from the right, find searches from the left. And the difference between find and index is how they deal with not finding a string. And I should stress again that these are all case sensitive. So if you want to do case insensitive comparisons, you need to convert their case first. The other thing I'll point out is many of these methods have extra optional parameters. And if you want more details on that, see the Python documentation for the string class. These extra parameters do things like let you search in specific parts of the string. There are some other string methods that will help us making comparisons, and most of these are the is methods, and these all return Boolean values, true or false. And these are mostly centered around checking if a string contains a certain type of characters. So isalnum, which stands for isalpha-numeric, returns true if the characters in the string are all alphanumeric. That means it returns true only if the characters in that string are all letters and digits. So in some of the examples we have here, we see cat is true because they're all letters. 5 cats is also true because that's 5 is a digit, so that counts. 1, 2, 3, also true because those counts as digits. Now, one important case to consider here is the high space cat example, where it's returning false. The reason for this false is that space character. So space character isn't considered to be a letter or a digit, so we get a false here. The next method is isalpha. This is very similar, but it only returns true if all the characters in the string are alphabet characters. That means just letters. So we get cat is true, but something like 5 cats is going to return false because it has a number mixed in there. So every single letter has to be a letter. If there's any numbers or spaces, like in 1, 2, 3 or high space cat, we are going to get a false. Isdecimal is very similar, but now we're just looking for digits, 0 to 9. So cat would be wrong because, or return false rather, because it doesn't have any digits and it has letters. 5 cat is also going to be false because it has to be all digits. 1, 2, 3 is going to return true because those are all digits. Now, one thing to keep in mind is even something like the decimal place doesn't count as a digit, so that would return false. It can only be the numbers 0 to 9. The next methods are islower and isupper. And these do what you might expect. They return true if all the letters in a string are uppercase, for isupper, or true if all the letters in the string are in lowercase, for islower. They do have a bit of a quirk, though, in that they don't count any spaces, symbols, or numbers, anything that's not a letter, so long as there's at least one correct letter in the string. These two examples here, we have capital C space 5 and then exclamation mark dot isupper, and that returns true because there's at least one capital letter and all letters in the string are uppercase. However, isupper on just 1, 2, 3 is false because there's no letters there. To reiterate, for the isupper method, all letters in the string have to be uppercase and there must be at least one letter. For islower, all letters in the string have to be lowercase, and there has to be at least one letter. Mixing in numbers is fine as long as there's at least one letter. It's the correct case. Last is isspace. This returns true if all characters in the string are white space characters. So white space isn't just your spacebar key, it's also things like tabs and line breaks. So in this first example here, you can see that a bunch of spaces, then a /t, /n, and a bunch of spaces is true because tab and line break are considered to be white space characters. These are any characters that are printable. They're sort of those invisible spaces. The other example, the space cat, returns false because it has to be all white space. It's not enough just to have one white space for isspace. Okay, let's take a look at an example. Here we want to write a program to check if a given email is valid. A valid email must have the following properties. 1, it has to have a length of exactly 15, including the domain. 2, it must end with @uwo.ca. 3, it must start with a letter. 4, the character before @uwo must be a number. For example, in Servos 5 @uwo.ca, the character that comes right before the @uwo.ca is a number. So it has to be a number. If it's anything else, it's not valid. And 5, it must be in all lowercase. If the email is valid, print out valid email. If the email is invalid, we want to print out a message explaining why it's invalid. So these aren't real email rules for Western or anywhere else, but they are some interesting rules that we can apply some of these methods we just saw to. So I have the solution here, but it might be a little bit more interesting to explore it in PyCharm. So we'll switch over to that now. So here we are in PyCharm and we have the program open. The first line shouldn't be too surprising. It's just letting the user input their email before we process it. And the way we're going to do this check is that we're going to start by assuming the email is valid. And we're going to store if the email is valid or not in this variable called email OK, and we're going to set it to true. So it's going to have the Boolean value true. And what we're going to do is each one of these blocks of code here is going to perform one of the checks. So we have 5 different checks defined in the problem. Each one does a different check. And if in any case we prove that that email is invalid, we're going to update email OK to false. Then at the end, we have a simple if statement that says if the email was OK, we say valid email. And otherwise, we say invalid email. So if it survives all these checks, the value should still be equal to true, and we get valid email. If it fails one or more of these checks, it's going to update it to false, and we get invalid email. So let's take a look at each one of these checks to see what they do. So the first check here is simply if the length of the email is not equal to 15. You may recall that the length function returns the number of characters in a string. So if the number of characters in the string is not equal to 15, we're going to enter this if statement. It's going to print out that the length of your email must be actually, it should be 15 characters. And it is going to update email OK to false. Now remember, these if statements aren't connected. They're all on the same indentation level, and they're not else's or else ifs. So that means when this if statement is done, execution starts again here on line 19, and then it does the next check. So these are all independent of each other. The next check is fairly self-explanatory. It's saying if not, so we're going to negate whatever the true or false value is of this, email.endswith @uwo.ca. So this is going to return true if the email ends in @uwo.ca exactly. And this not here is going to flip that. So if it ends in uwo.ca, it's going to return true, and the not will then turn that into false. So it's not going to enter this if statement. It's not going to run this block of code if the email ends in @uwo.ca. If it ends with anything else, then this block of code will run. And we will print out your email must end with @uwo.ca, and we'll update email OK to false. The next check is we want to check that the email starts with a letter. So this one's getting a bit more tricky. And what we're doing here is we are getting the character at index 0 in the string. Remember, strings are indexed 0 starting at the left, to however many characters -1 to the right. So 0 would be the very first character. And then we are checking if it's alpha. So that's using that string method to check if this is a letter character, not a number or anything else. So this will return true if the string starts with a letter. And then we're using the not operator to flip that. So if it returns true, it changes it to false. That means it won't run this block of code. If it returns false, it changes that to true, and then we enter here. What that means is if the string doesn't start with a letter, we run this. And if it does start with a letter, we just jump over it and start at line 29. Okay, this is the complicated check. This is where we wanted to check that the character before @uwo.ca is a number. So in this case, we are using the rfind method. If you recall, rfind searches for a substring starting at the right, moving to the left. And what we're looking for is the text @uwo.ca. So once it finds that, it's going to return a number. And that number is going to be the index of where it found @uwo.ca. And we're going to store that index in I. And then we're going to use that to try to find the character that comes before it. So if we were just to say email I, it would get the @ sign, because that's where it found it in the string. But if we say I -1, that means it's going to be the character before the @ sign. And then it's going to store that in the variable char. Then we can actually do a check on it. Here we're going to say if not char.isdecimal. So we're saying if the character is a decimal, meaning it's like a number, 1, 2, 3, all the way up to 9, then this will return true. But then we're using not to flip that. So if it found a decimal, it would change it to false, which means we wouldn't run this code, because this code's only if it wasn't a decimal. If it wasn't a decimal, then we'd enter here and tell them that they need to have their username end in a number. The next check, or the last check, is fairly straightforward. We're just checking that the email is in all lowercase, and we're doing that with the islower method. Same idea. So that might be a bit complicated, especially check number 4 here. So let's actually run this in debug mode, the breakpoint, and see how things work. And we'll start off with a valid input. Okay, let's take a look at the variables. So right now we have a variable email and it has dservos5@uwo.ca. Move to the next line, and you can see that we now have email OK equals true. And that's where we're keeping track if this email is valid and if it's passed all our checks. Next, you can see that we're now on the line where we're checking the length of the email. In this case, the email is exactly 15 characters. So that means 15 not equal to 15 is going to be false. So we're going to jump over that and end up on the next if statement. If it was equals equals, then we'd go in. But since it's not equals, that means we only enter here if it wasn't equal to 15. It means the number of characters weren't equal to 15. Okay, so we jumped over. And now we are checking if it ends in @uwo.ca. It does. So that means we're not going to run this. We're going to jump over and go to the next if statement. Okay, we're at the next one. It's checking if the first character is alpha. In this case, that first character is going to be a lowercase d, which is an alpha character. So we're going to jump over. And now here's the more tricky part, where we're going to actually try to find the location of @uwo.ca in the string. So let's run that line. And you can see we now have a variable 8. So if we were to count this out, remember we start at 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So our find returns where it found the first character in the substring, which is the @ sign. So it's telling us that index 8 is where that @ sign is at the beginning of @uwo.ca. Now what we're doing here is we're subtracting it by 1. So we're going to move this way. So we're going to get the character that's before the @ sign, which in this case is a 5. So we can see that char is equal to the character 5. So it retrieved at 8 minus 1, which would be 7, and that would be the index right here that has a 5. The next line is going to check if specifically char is a decimal. Now remember, the isdecimal method returns true if it is anything that is a digit. So digits 0 to 9. It is in this case, so we get true, but we have not in front of it. So it switches that around to false, which means we don't enter this if statement. We're going to jump down to the next check. We're checking if it's all in lowercase. It is. So we're going to skip this, and we're going to finally get to the last part where we output it. Is email true? Email okay true? And that still is true that we can see. So that means we're going to enter and print valid email. And you can see we get valid email, as we'd expect, since this was a valid email address. Let's try tracing through with some new values. And let's try to violate a few rules this time. Let's say 7 blogs, exclamation mark. Let's add some capital characters in there. And we'll still do uwo.ca. Okay, so let's take a look. You can see we have that mess in email right now. And now we're going to set email okay to true. So we start off assuming it's valid. And then we try to find a contradiction. So first we're going to check the length. The length was okay. It happened to be 15. So we're moving on to the next email, or the next check rather. And we're going to check if it ends with @uwo.ca. This email still does. So we're going to skip that. And now we're checking if it is alpha, the very first character. Now this is going to be our first problem because that is a 7, the first character at index 0. That means that this check should fail and we should enter it, and we're going to update email okay to false. So you can see we do enter. We're printing out to the console. You can see in the console now your email must start with a letter, and we're going to update email okay to being false. So you can see now email okay equals false, so we know that it has been invalidated. Now we're doing this check to see what the character in front of the @ sign is. We get 8 in this case. So again, it's at character 8, the @ sign. We subtract 1 to get the character in front of it. That would be index 7. And that is going to be stored in char. So we get the exclamation point. And then we're going to check if that is a decimal. It's not. So that means we enter this if statement. We're going to print your email must end in a number, or your username rather. We get that in the console. And again, it's going to update email okay to false, but it's already false, so it doesn't really do anything. And we're going to check islower. In this case, we do have some uppercase characters there. So that's probably going to cause a problem. And it does. We enter into that if statement, and we're going to output to the console the issue. Your email must be all lowercase. And again, we update email okay to false, but it doesn't matter in this case because it's already false. We get to the final check, and we're seeing, did we find a case where it was violating one of those requirements? We did, because we're at false. So instead of saying valid email, because this is false, we're going to do the else, which is invalid email. And you can see what we got in the console. So we got all of the issues with the email. It must start with a letter, username must end in a number, and email must be in all lowercase. And then we finally get invalid email. So let's give it one more run or two, just to try out a few more values. Okay, let's put in a new one. And let's make it too short this time. Call it short @uwo.ca. We'll trace through a little bit faster this time. So this is the one that it should fail. So now we are less than 15, and this is checking that it's exactly equal to 15. If it isn't exactly equal to 15, we enter the if statement because it's not equals. So in this case, it's not. So we're going to get the length of your email must be exactly 15 characters. It's going to be printed to the console, and it's already going to mark email as invalid, like it just did. Now we're checking if it ends in @uwo.ca. It does. We're checking if the first character is a letter. It is. And now we're looking for, is there a number in front of that @ sign? So this time we get a value of 5 because the @ sign's closer to the beginning now because this is a closer string. But if we count 0, 1, 2, 3, 4, 5. So it's at index 5. So 1 before that, subtracting 1 will get us a T. You can see char equals T, and we are going to check if that's a decimal. It's not, because that's not a number. So we enter, we print out that error to the console. Let's see it now. And again, we update email OK, but it's already false. Now we're going to check if everything is lower. It should be. And now we're going to check, well, did we find a violation of one of the rules? We did, because we set this to false. So we're going to print out invalid email. And here we go. So in this case, there was 2 issues. It was too short, and your email username must end in a number. So we get invalid email. Now, there is one other case we should address, and that is find right now is looking for a @uwo.ca at the end of the email address. But did we account for the case where that's not going to happen? What if there is no @uwo.ca? Maybe they violated this case here. Okay, this time we're going to add dan@gmail.com. That's not my real email, so please don't email them. And we're going to go through it. So I'll skip over stuff we've already seen. It's going to be true. And now this one we haven't seen fail yet. In this case, we're looking for @uwo.ca at the end, but we don't have that at the end. We have Gmail. So we're going to enter in, print out the error message, update it to false. In this case, we're checking if it starts with the letter. It does. And now this is going to be a little bit more interesting. So we're going to try to find @uwo.ca, but it doesn't find it. So we get -1. Now we're going to have I, which is -1, -1. So that's going to be -2. So this case is not really doing the check correct if it's missing @uwo.ca, because it is now going to be trying to do a negative string index. And let's see what happens. So now we're getting an O. Why did we get an O? Well, if you remember, if we give a negative string index, it starts at the right-hand side. So -1 would be M, and -2 would be O. So this check is not working correctly for the case where @uwo.ca is missing. So we could take a look at how we could fix that. But first, let's just run the rest of the code. So it does overall correctly identify that it's an invalid email, but that's not really correct the way we're getting that character. So there's a few things we could do. Instead of looking for @uwo.ca, we could just look for the @ symbol, and then maybe add another check just to make sure that there is an @ symbol. So maybe we could do @, and now we could say if not char is decimal, we could add an OR. So we could say if I is less than 0, actually we could add a new check. After this, we could say if I is less than 0, print error no @ in email. And in that case, the email would also be invalid. Emails have to have an @ sign. And then we only want to do this check if there actually is an @ sign. So this is a little bit more complicated now, but first we're checking, is there an @ sign in the email address? If there is not, it's less than 0, that means we've got a negative index. Then we're going to say error no @ in email. And then we're going to set it to false. Otherwise, if there is an @ in the email, we are going to run the same code we had before, which is going to check that the character before the @ sign, at least the rightmost @ sign, is a digit. So let's give this a run and see if that worked, what we just changed. Okay, so we'll have to do a silly one that doesn't have a @ dan@gmail.com. And we can see your email must end in @uwo.ca. That's coming from here. That failed this test. And then we're also failing our new test that we just added, which is no @ in email. We can run it the other way, where we actually have it So let's see, tservos5@uwo. It's still working. We didn't break anything. Still a valid email. It's still finding the @ We didn't really need to make sure that it was at uwo.ca. And we're checking that that is a digit. It is, so everything checked out. And we could try a case where that doesn't check out. So we can say alice@uwo.ca. And we can see that your username must end in a number, so our new improvement is working. There are many other checks we could add to make this even better. For example, we could check how many @ signs there are with like the count method and try to narrow it down more and more to make sure this is more valid. But the important thing here is how to use these string methods and string comparison operators to sort of process strings. I'll save this as the 2.12b with my changes. Okay, we're back to the slides. Right now, I just have the example up before we actually made the changes. If you want the copy with the changes, it's going to be listed as example 2.12b on our learning management system. So you have both before and after. That's all I have for you in this video, and I highly recommend you try out playing around with examples like example 212 just to try different things. Maybe try adding another check that checks if there is more than one @ sign in the email address, which would make it invalid. Or maybe a check for certain characters that are invalid in an email address. The best way to learn programming is actually by trying out new things, learning, debugging your code, and from practice. Memorization probably won't be enough. Thank you for watching, and have a great day.